Hello, everyone. Welcome to the Advanced Manufacturing Technology for Welded Structures course. Today, we will study the important topic of basic knowledge of assembly positioning. I'm your lecturer, Xiao Yong. This lesson is divided into two parts, and we'll begin with the first half. Assembly positioning is crucial in mechanical manufacturing and welding, and it is closely related to real-world production. Before we begin, let's clarify the basic tasks of assembly: positioning, clamping, and measuring. The goal of positioning is to determine the accurate location of welded components within the structure. In fact, correct positioning directly determines the quality of a welded structure. For example, the boom of an excavator requires precise positioning of the front bracket, middle bracket, rear bracket, and main plate. Errors can affect the machine's digging performance and service life. Let's move on to the first key topic: basic rules of positioning. Any unpositioned workpiece has 6 degrees of freedom in a 3D Cartesian coordinate system. Translation along the X, Y, and Z axes, and rotation about these axes. To secure the workpiece accurately in a fixture, regardless of its shape or structure, we apply the 6-point positioning rule to restrict all 6 degrees of freedom. The fixed points used to restrict these freedoms are called positioning support points. This is like placing a box steadily on a table. You need to restrict movement and rotation from different directions. Now let's look at common positioning methods. For box-shaped workpieces, positioning is done using the 6 faces of the cuboid. Set points 1, 2, and 3 on the XY plane to restrict Z-axis translation and rotation about the X and Y axis. Set points 4 and 5 on the YOZ plane to restrict X-axis translation and rotation about the Z-axis. Set point 6 on the XOZ plane to restrict Y-axis translation. This involves several important concepts of positioning references. The 3 positioning points on the XOY surface restrict 3 degrees of freedom of the workpiece. This surface is called the primary positioning reference. The larger its area, the more stable the positioning, and the higher the positional accuracy between parts. Therefore, the largest surface of the workpiece is usually selected. The 2 positioning points on the YOZ surface restrict 2 degrees of freedom. This surface is referred to as the guiding positioning reference. The greater the distance between the 2 positioning points, the more accurate and reliable the alignment of the workpiece to the fixture plane. Typically, the longest and narrowest surface of the workpiece is selected. The single positioning point on the XOZ surface restricts the final degree of freedom of the welded part. This surface is called the thrust positioning reference, and is usually the shortest and narrowest surface of the workpiece, ensuring stability and precision during the welding process. When positioning disc-shaped workpieces, their large end face and short axial length make the larger end face commonly used as the primary positioning reference surface. This ensures stable installation and reliable clamping, allowing for precise positioning and secure assembly. For bushing-type workpieces, known for their long axial dimensions, accurate rotational support relies on the coaxial bearing journals at both ends. In the 6-point positioning method, the selection of positioning points 3 and 6 is particularly critical to ensure stable alignment and precise machining during the assembly process. Let's now discuss how to choose positioning references. The first principle is coincidence with the design reference. Try to align the positioning reference with the design reference to eliminate or reduce errors caused by non-coincidence of datums. If the workpiece surface is uneven, positioning blocks can be used to contact the workpiece at small points, lines, or surfaces to reduce errors. The clamping force application point should be as close to the weld area as possible to minimize deformation caused by clamping force or welding heat stress, improving the overall weld quality. When selecting references, also consider the welding structure layout and assembly sequence. A well-planned sequence is vital for structural performance and stability. Also, standardizing the reference surfaces used in fixtures simplifies production, improves fixture design and manufacturing, and enhances efficiency, enabling standardized and serialized production. In real-world welding, we use both complete and partial positioning. Complete positioning restricts all 6 degrees of freedom to ensure machining accuracy. Partial positioning restricts only some degrees of freedom based on the welding needs, allowing better control of welding stress and deformation. I hope today's lesson has deepened your understanding of the basic rules of assembly positioning, common methods, and reference selection. We'll continue with the second part in the next lesson. That's all for today. Thank you for listening. See you next time.